Hey everybody, it's Mr. N, and today we are going to talk about the product and the quotient rules. So let's go ahead and start off with the product rule. So these are going to be used when we are taking derivatives, and if f and g are both differentiable, then we know that the derivative with respect to x, if I'm multiplying two functions, f of x times g of x, this becomes the first function times the derivative of the second function plus the second function times the derivative of the first. Now, if you do it like this, no, we can't distribute. We can't just say f prime of x is going to be f of x times g of x. That's not how it works. So here it is again. It's going to be the first times the derivative of the second plus the second times the derivative of the first. So I often get asked, well, can't I just flip-flop it as long as I know I'm taking the derivative of one, multiplying it by the other, then the derivative of the second one and multiplying it by the other? That's fine. But typically, this is how we memorize it, but some teachers do teach it the other way. In other words, they just flip these two around. Again, since this is addition in between, it doesn't matter. But typically, we're going to say first times derivative of the second plus the second times the derivative of the first. So if I put it in like a notation like this, it's going to be f prime of x. For this will be f of x times g prime of x plus g of x times f prime of x. So basically what you are doing is make sure you're multiplying each one by the derivative of the other function. That's pretty much it. All right, so now let's move on to the next one, which is the quotient rule. Now this one gets a little bit trickier, and we have to follow the directions on this one. So if we have the derivative with respect to x, and this time I'm dividing, f of x divided by g of x. Well, this is a bit more complicated. And again, your author does prove it in the book, so Stewart does prove it, so you can take a look there. But this one will be g of x times derivative of f of x, so the bottom, and then I'm taking derivative of the top, minus, over here it's going to be f of x times derivative of g of x, so the top times derivative of the bottom, and then I'm going to take this g of x, which is on the bottom, and square it. So here's how we memorize this. I put it in the little cloud over here. Bottom times derivative of the top minus the top times derivative of the bottom over the bottom squared. So bottom times derivative of top minus top times derivative of the bottom over the bottom squared. bt prime minus tb prime over b squared. So bottom derivative of the top minus top times derivative of the bottom over the bottom squared. Again, there are different ways of remembering this. I will let you try to figure out some of those ways. I will talk about those ways in class as far as little things to remember and songs and all that. So we'll discuss that. So let's get on to the next slide over here, and let's take a look at some of these. So one thing I want to remind you is when we did the power rule, I forgot to mention this then, so I'm going to mention it right now. If you have a negative power, it's just going to follow the same exact property. So we're going to say negative n times x, and then we have our negative n, and then subtract 1. So let's do a couple of these examples just to make sure we understand that. Over here, f prime of x, this is going to be negative 5 times 2, which is negative 10, x, and then I subtract 1 to the negative 6. For the next one, f prime of x, I'll give you a second. You can pause, you could do it, and then check my answer. All right. So this I will multiply through. So this time negative 3 times negative 2 is going to give me 6x, and then I'm going to subtract 1. I get negative 3, plus over here it'll be negative 5x to the negative 6. So f prime of x, let's just clean this up, will be 6x to the negative 3 minus 5x to the negative 6. And then if we come across problems like this, you don't want to have to use the power rule on this because you've got a constant up in front. So it's easier just to change this and rewrite it as x to the negative 2. Now take the derivative of it. So we're not going to want to use a quotient rule on it, is what I should have said. So no quotient rule, just change it. It's easier to do it with a power rule. So this becomes negative 2x to the negative 3. Now, if you wanted to rewrite this, I'm on the free response, leave it like this, but if you see it in multiple choice, they will rewrite this as that. Okay, so over here, f of x, we will rewrite this to be 3 over 2 x to the negative 5. Now, f prime of x will end up being negative 15 over 2 x to the negative 6. And again, you can rewrite it. You don't need to on the free response, leave it like that, but on multiple choice, you may see the answer written out like this. Okay, so either one I will take. So in summary, let's summarize everything we have done here. Over here, this is for the past few days. I'm going to do a few examples down below, and then we'll do some in class. So in summary, the derivative of a constant is 0. Over here, the derivative of x to the n, which is our power rule, is going to be n times x to the n minus 1. If a constant times a function, you just leave the constant there and take the derivative of it. If you've got addition within, then you can distribute that. If you've got subtraction within, then you can distribute that. So that's just like when we had something such as 3x squared plus 2x minus 5, right? These are all additions and subtractions in between, so we just take the derivative of each one individually. And then we got today to the product rule. So if you're multiplying, then you have to use the product rule, first times the derivative of the second plus the second times the derivative of the first. And then the quotient rule if you're dividing bottom times the derivative of the top minus top times the derivative of the bottom over the bottom squared. Okay, so let's do a few examples, and then we've got some in-class examples that we will do later in class. So let's look at this first one. This 3 should not be here, it's just a typo. That's the equation, and we want to find the direction should be find the derivative of each. Okay, so on this first one, we're going to go ahead and it's a quotient, so we want to use the quotient rule. So y prime will be the bottom, 3x minus 2, times the derivative of the top will just be 3 minus the top, 3x plus 5, times the derivative of the bottom, which will also just be 3 over the bottom squared. Now, cleaning this up, over here, y prime will be, it's going to be 9x. Let's see, we can erase that. 9x. Get back to my pen. 9x minus 6. Now, over here, this will be 9x plus 15, and then don't forget to distribute this negative. So negative minus 9x minus 15 all over this 3x minus 2 squared. I'm running out of room, so let's finish this right here. Now, these 9x's will go away, and I'll have negative 21 over 3x minus 2 quantity squared. So that is the derivative there. All right, on the next one. In fact, I could probably move this up. You're going to just see that it says in-class examples, but those are not written right here. You'll get those in class in your notes online. All right, let's take a look at this next one. I have this situation where this time, since this is a -1, I will rewrite this. Instead of using a product rule, I'm going to rewrite this to say 1 minus x divided by 1 plus x squared, right? Because that's what that will end up being. So all of these are quotient rules. I can give you an example of a product rule in a minute. So let's take a look at this. This will become y prime becomes the bottom, 1 plus x squared, times the derivative of the top, which will be -1, minus the top, 1 minus x, times the derivative of the bottom, which will be 2x, over this bottom, 1 plus x squared. All right, let's clean this up. So y prime will be, over here you'll get -1 minus x squared, and then over here we're going to get 2x minus 2x squared, and then don't forget the floating negative right there. So we'll get minus 2x plus 2x squared all over 1 plus x squared. And cleaning this up one more time, this becomes x squared minus 2x minus 1 over 1 plus x squared. Now, you can try to factor the top to see if anything will reduce out, but this one will not. So we're just going to go ahead and leave it like that. Okay, and finally, this last one. Let's take a look at what we have, and we will go with it. Okay, so again, we are going to need the quotient rule. So f prime of x will be the bottom, 1 minus x cubed, times the derivative of the top, which will be 2x, minus the top, which will be x squared, times the derivative of the bottom, which will be negative 3x squared, all over the bottom 1 minus x cubed squared. So distributing this, f prime of x will be, this will be 2x minus 2x to the fourth. Over here, you will get the negative times the negative, so positive 3x to the fourth all over this 1 minus x cubed squared. Okay, now combining like terms, f prime of x will end up being, this will be x to the fourth minus 2x all over the, you could take an x out, but that's not going to matter because there's nothing I can reduce it with on the bottom. So that is the derivative there. Let's see if I can squeeze in a product rule. Since I didn't do one, we'll do that right over here instead of saying in-class examples because we're running out of room. We'll see if we can squeeze in a product rule. So f of x we'll say is x minus 3 times 2x to the fourth plus e to the x. Now, could you work this out without, by foiling it out and then taking the derivative? Sure you can, but it might be longer. So it just depends on the situation. But this one, we're going to do it with a product rule. So f prime of x will be the first, x minus 3 times the derivative of the second. Now, the derivative of the second here will be 8x cubed plus derivative of e to the x is just e to the x times the second, or plus the second, 2x to the fourth plus e to the x times the derivative of the first, which would just be 1. So cleaning this up, I'm just going to get rid of the 1 over here. I'm not going to bother foiling this out. Only bother if it's multiple choice and you're looking to match the answer. Otherwise, you may just leave it as this, the way I'm leaving it. You can just leave it like that. So that is an example of a product rule. Then we've got a bunch more that we will do in class. So thanks for watching. Hit that like and subscribe button, and I will see you guys in the next video. You're going to need to